All right, today we are going on a journey deep into the heart of Java. We're going to see step by step how an idea becomes a living, breathing program and how this one language powers so much of the digital world we use every single day.
I mean, think about it for a second. Your banking app, the games on your phone, these giant enterprise systems. How do they all seem to work together? Well, you've probably guessed it. The answer is very often Java. It's this invisible engine running behind the scenes. So the real question is, how did it get to be so important? That's what we're here to figure out.
To really get Java, we have to jump in our time machine and go way back. Let's start at the beginning, with the big problem it was designed to solve right at the dawn of the public internet.
Okay, check out this timeline. We're in the early 90s and the web is just starting to explode. But for developers, it was kind of a nightmare. Just imagine you write a piece of software and then you have to completely rewrite it for Windows, then again for Mac, then again for Linux. It was a huge pain. Then, in 1995, Sun Microsystems comes along with a very bold solution.
And this was it. This was their revolutionary promise. Write once, run anywhere. Such a simple phrase, but the idea behind it was massive. You write your code just one time, and it should work on any computer, anywhere. The big question, though, was, how is that even possible?
Well, this right here is the secret sauce, the Java Virtual Machine, or JVM. The best way to think of it is as a universal translator. You don't write your code for Windows or Mac, you write it for the JVM. Then, the JVM on each of those machines handles the tricky part of translating it for the local hardware. This was the magic that made it all work, and honestly, it was a total game changer.
But you know, it wasn't just about running anywhere. Java was also designed to be just plain better. If you look at this chart, compared to older languages like C++, Java handled memory for you automatically. That alone wiped out a whole category of common bugs. And since it was born for the internet age, it had security built in from the ground up, which was a huge deal.
Okay, so that's the big picture. Now let's roll up our sleeves and start building. What are the absolute basic materials we need to make a Java program?
First things first, variables and data types. You can literally think of these as the raw materials for our project, the nuts, bolts, and steel plates. A variable is just a box you can put some information in, and the data type is the label on the box that says what kind of information can go inside.
So here's a look at our starter toolkit. We've got int for whole numbers, double for your decimal numbers, char for just a single character, and boolean, which is just a simple true or false. These are the absolute essentials you'll find in pretty much any program you write.
Now, a pile of raw materials doesn't do much, right? We need to put them into motion. That's what control structures do. They're like the gears and levers of our machine. With something like an if-else statement, our program can start making decisions. With a for loop, it can do a task over and over again. This is how we breathe logic into our code.
All right, we've got the nuts and bolts down. But to build something truly powerful and complex, we need a smarter design. It's time to give our program a brain with something called object-oriented programming.
And this analogy here is the absolute best way to understand the core idea. A class is like a blueprint for a house. It defines what a house should have, doors, windows, a roof. An object is the actual house you build from that blueprint. And what's so cool is that you can build an entire neighborhood of unique houses, all from that one single blueprint. Now, this whole approach is built on 4 key principles. Encapsulation just means keeping related stuff bundled together nice and safe. Inheritance is a huge time saver. It lets you create a sports car blueprint that just reuses everything from a basic car blueprint. Polymorphism sounds fancy, but it just means a command like drive can work differently for a car, a truck, or a bus. And abstraction is all about hiding the messy details. You just turn the key to start the car. You don't need to know exactly how the engine works. So as our program gets bigger and more powerful, things can get messy fast. And just like a mechanic's workshop, a messy workshop is an inefficient one. We need to stay organized. In Java, the main way we stay organized is with packages. And really, a package is just a fancy name for a folder. You put all the code related to user accounts in one package and all the code for payment processing in another. It keeps everything clean, tidy, and easy to find when you need it. We also need ways to organize our actual data. For that, Java gives us different kinds of containers. An array is like an egg carton. It has a fixed number of slots, and that's it. An array list, on the other hand, is more like a shopping bag.
It's flexible and can grow automatically as you add more stuff to it. So, we've built this amazing, well-organized machine. But right now, it's just sitting there, humming to itself. What good is that? It needs to be able to interact with the outside world.
And the way our program communicates is through input and output streams. Just think of them as simple communication channels. An input stream lets the program read information from a file or the network. An output stream lets it write information out. This is how our program actually talks to things. But streams of data aren't very friendly for us humans, right? So we need to give our program a face. That's where a GUI, or graphical user interface, comes in. With tools like Swing, we can build the windows, buttons, and text fields that let a real person interact with our machine. It's the control panel.
You know what else a useful program needs? A memory, a way to store information even after it's turned off. That's what databases are for. And JDBC is the special bridge that lets our Java program connect to a database. This is a huge step. It's what turns a simple program into a powerful data management tool. And connecting to a database isn't some kind of dark art. It's a very clear, step-by-step process. You load the right driver, you open up a connection, you send your request, you get the results back, and then you close the connection when you're done. It's a systematic and reliable process every time. Okay, we are almost at the finish line. We've built our machine, we've organized it, we've connected it to the world. Now for the final, crucial step, making it smart, resilient, and, well, alive.
Because let's face it, in the real world, things go wrong. What happens when the internet connection drops? Exception handling is what lets the program deal with those errors gracefully, instead of just crashing. And multithreading? That's the program's ability to multitask, to do more than one thing at once. It's why an app can download an update in the background while you're still using it, making it feel fast and responsive.
So there it is. From that simple idea, write once, run anywhere, to this massive ecosystem that powers some of the biggest systems on the planet, Java really does give you a complete toolkit for innovation. It gives you all the pieces you need to build. So the only real question left is, what problem are you going to solve with it?